Hello everyone, welcome to a new episode. Last time we did some refactoring. Today we'll continue with the stairs, moving up and down stairs so we can change floors. So let me set a timer and let's get started. Now what we already have is we can move up the stairs using the party ascend stairs function, and obviously we could create one that goes down, but this implies that you can move onto the stairs and then decide to use it or not. And that's, I guess, the way, for instance, the first wizardry game did it, where a stair could be more like a ladder or a step ladder. And another solution could be to do this more like something like Eye of the Beholder, where a stairs is something that if you move onto the tile that represents the stairs, you automatically move up or down the stairs. And I think I like that solution better. So that means that we need to change these tests a little bit to describe that situation. But okay, let's just see how far we can get. It will be, from a UI point of view and implementation point of view, actually easier, and it will cut down on the number of functions we need as well. So you could say that when a party moves into a staircase, the floor number should increase by 1. And we could create a simple map, something like this. And instead of using this function, we could say party, move party to the right. And this, I believe, is done like that. And we can build and run in this test. Okay, and this one doesn't work because move party doesn't take stairs into account. So what we could do is we're checking here to see if there's a wall. What we could do is say if map has stairs up at new position, we say current floor plus 1. And now this test passes. And we no longer need this test, because that one was trying to ascend while there's nothing there. Meaning we can also get rid of this function now. So we have all these tests completed. This is our dungeon crawler. Change how ascending stairs works. And we can do the same if we want to move downwards. So let's copy this test and say when a party moves into a staircase leading down, the floor number should decrease by 1. So we have a different kind of stairs. Again, we can go right, and now the floor number should be -1. Let's go in here. So we could say that if map has stairs down at new position, current floor a -1, and we don't have to have stairs down, but we can add this one. we need a list of stairs down and add this one. And by now we start seeing a lot of repetition, but we'll fix that in a minute. So we have a has stairs down. And now this test should pass. Okay. Let's quickly commit this one. And now let's start refactoring this a bit. So we have this function called hasWall at hasStairs at hasStairs down at. I think what we need is an actual tile data structure. So I'll call this a tile, and we have the case floor. We have a case called wall, a case called stairs up and stairs down. And we can create a static one that creates one from a character. So we could call it character to tile. And this will return a tile. And we'll switch on the character, and if it's hashed assign, we'll say we return a wall. If it's this one, we'll return a stairs up, and otherwise it's a stairs down. And if it's anything else, for now we will just return a floor, assume it's a floor. So now we can initialize this one also by saying, let's add a list of tiles. This will be a dictionary of coordinates to a tile. And then we can also here say so this is a column and a row. This will be a tile, character to tile, and we'll send in our map array row column. So we have this one now here as well. This should still pass. Now we can create a new function called tile add. That returns maybe a tile. Otherwise we return nil. Well, maybe it's better to use a card statement. Actually we can just return tiles coordinates. And we could say this should all still pass. We can first convert this one to use this new function. So we could say tile at coordinate equals a wall. Tile at coordinate equals stairs up. And tile at coordinate equals stairs down. Okay, this still passes. Let's quickly commit this. So this is a refactoring, introduce a list of tiles in map. And our world can now use a slightly different solution. So we can still check if the map is actually in enterable position. So we could say map well, we could just say switch map tile at new position. Then we have all these. So if it's a floor, then we can just say the new position. We can just put the party position as the new position. If it's a wall, then we don't do anything. If it's the stairs up. And this is a bit risky because we now need to do two things. And if it's stairs down, we also need to set the new position. Oh, and if it's anything else, I assume we don't do anything. So let's see if this still passes all the tests. And it doesn't, so I'm probably forgetting something. So we're no longer moving positions. And that's probably because by now we assume we're sending back, don't send anything back. Let's assume that every coordinate is a floor unless specified otherwise. Okay, so now all the tests pass. Leave dependency on has. And we can now safely delete these ones. Oh. In our view, we can say if it's a wall, okay, so test still pass. And in the map initializer, we can say, we can also get rid of these ones. At least that's what I thought. The min x, min y, and so on, we need to check in a store in a different way. We can use the tiles. This should still work. And we no longer need to set these ones. Okay. So we save, remove walls and stairs properties from a map. And now we have this, we can actually add these to our game view. So let's assume that we have a function that creates a cube if it's a wall. Let's create something similar that creates a stairs up. And the stairs up will be, well, it will be transparent. And these should be, well, let's try a number. We'll see what happens. And let's create also a stairs down. So this could be, we'll just have to see what kind of color comes out of this. And we can say in our view that we switch on world map tile add coordinate. If it's a wall, we do this. If it's a stairs up, we do more or less the same thing, only this time we create a stairs up. Is that what we called it? What? Oh. And we can do a stairs down. And we can create a default case that doesn't do anything. And we can create a map that has both the stairs up and the stairs down. So I think these are in our presentation. Right, so we start here. Let's assume that there's a stairs up or stairs down there and the stairs up here. So let's see if we can build and run this. So it looks like this is our stairs because it's transparent. I don't think it's the right color for stairs, but okay. And this one is a stairs as well because it's indeed how do you say, transparent. So I think they should be more transparent and maybe they shouldn't be as high, so make them a bit more easily a bit easier to see. Let's see what happens if I make them half as big. And also for now, let's try and see us actually moving up and down by very simply saying print moving up and moving down. So this is now, we're moving up. And this is us moving down. I don't like how the stairs show just yet. Let's see what happens if I don't. Maybe we need an actual model for them, but let's see what happens if I just give them don't give them an alpha value. it looks like they are sort of behind something else. Which is kind of weird. So they do get triggered correctly. They don't look like I envisioned them to look. I thought you would just have a floating box, and for some reason they either obscure the other thing behind it completely, or we just can't see it very well. Let's see what happens if I take a sphere. I just want to see if I can get a bit of a better view handle on why this looks the way it looks. Okay, so now this sphere is very clear where it's at. So perhaps using a cube to show the stairs isn't such a great idea. So that might mean that we need to import actual models. I'll just create another sphere for the other one as well, just to give it so we can see it. Okay, so now we have the spheres representing stairs, which are kind of weird, but at least they are visible. This also means that I think we will need to add proper models, and that could be a nice thing to work on for the next episode. So for now, I'd say, is there anything else that we can do? So let's quickly note down what we worked on today. So we changed you move up or downstairs when you move into them. We added map can now be inspected for tiles at a position, and we added a stair visual stubs to the game view. Okay. This one is indeed done, and this initializer for map is still a bit confusing. The thing what I'm thinking about is, if I am assuming that everything that's not that is not specifically mentioned as being something special is always a floor, maybe I can only enter these tiles, the ones that are not floors. So perhaps I could say, if I say red tiles is a thing like this, and if I then would say my own tiles is red tiles.filter, if this is not a floor. Do my tests still pass? Okay. Does this game sort of still run? Okay. Okay, cool. I think this then we are done for now. Next time I want to work probably a bit on the visualization part. So let's try and get an actual stairs model into the game. And also let's try and make it all, maybe get rid of all the crazy colors so it becomes a bit clearer what are things that we actually need to look at and pay attention to. So thanks for watching and have a great day.